Okay, so now that we have an understanding of both set builder and interval notation, let's try doing some practice by converting between the two types. So let's say we have the first one, which is open bracket, negative infinity to 3, close bracket. So basically, we want to convert this to set builder notation. Now we know that interval notation, it must be in the real numbers set. So let's begin with that. So x is an element of real numbers such that, now what's our condition? Well, clearly we can see that x tends to negative infinity. So all negative numbers are in this category, right? We also see how that ends at 3. So clearly it must end at 3. And because of this close bracket, this tells us that it has to be less than or equal to 3. So what we can do here is write x is less than or equal to 3. And that's our first set builder. Now for the second one, this one looks a little bit different, but it shouldn't be that bad either. Notice here how -1 is not included in either of these sets. What this means is that there's probably a hole at -1 because we skip over that one point because we cover everything else except for -1. So let's do what we normally do. X is equal element of real numbers such that, now here we can simply say x is not equal to -1 because observe, we go through every single value here except for -1, right? Because this is an open bracket, not a closed bracket, right? So hopefully that was pretty simple. And we're going to do some examples with converting set builder notation to interval notation. So let me clear all this and paste this in. Okay, so now we have our set builder notation right here. Oops. Okay, so for the first one, we have x is element of real numbers, of course, such that x is greater than 1 but less than 5, less than or equal to 5. Now this is a good reminder to recall that the open bracket means less than, it does not have the equals, so we can put 1 here. But when we have an equals in there, we have to use the square bracket like this. So x is between 1 and 5, however 1 is not included but 5 is. Let's look at the last example. Notice how this is a little bit different, where our condition is x is less than 5 or x is greater than 20. So I'll draw this on a number line for your aid. So let's say we have this number line, we have 5 right here, and we have 20 right here. What this means is all numbers less than or equal to 5 are included in this set. So numbers such as 4 is included. We can do something like this, right? Because all numbers less than 5 are included, and make sure this is a dot, right? Next, or, which means one of these two conditions must be satisfied. So if it's not less than 5, less than or equal to 5, it must be greater than or equal to 20. So we just start with a dot and we extend. Notice how we try to put something in the middle here. Let's say 10. It would not work because 10 is not less than or equal to 5 or greater than or equal to 20. Right? So this is what we're aiming to write in our interval notation. So let's start with, we start from -infinity because that is always less than 5, less than or equal to 5. 5 here. Close bracket because it's less than or equal to. We use the union to combine these two sets. We can imagine this as one set and this as a second set. So union, our second set, which is close bracket 20, comma, infinity, and that's our interval notation for this set builder notation. And we are done. Hopefully this video was helpful, and I'll see you in the next